Alright, the last thing we're going to have a look at in our induction, so this is the final video on induction, is using induction to prove first order recursive formulas. So recursive formulas or recurrence relationships are a formula used when one term is defined in terms of one or more preceding terms. So a recursive definition of a function allows you to evaluate the function at a certain value of n using values of the function at some other values. For example, t of n is equal to 2 times t to the n minus 1. A closed form definition allows you to calculate the evaluated function to be evaluated directly from the required value of n. So for example, Tn equals n squared plus n minus 1. So example 1, a sequence is defined as u1 is 2, u2 is 6, un is 6u to the n minus 1 minus 5u to the n minus 2 for n is greater than 3. And we're proving by induction that the closed form of the definition is un equals 5n minus 1 plus 1. The first thing we need to do is prove our first two initial cases using this thing here. So prove, first of all, n is equal to 1. Well, that's equal to 5, 1 minus 1 plus 1, which is equal to 2, which is what we had up here. And then n is equal to 2. We're going to prove that it's 5, 2 minus 1 plus 1, which is equal to 6. So we're proven for our initial cases. So prove initial cases. Next, we're going to assume true, not for n is k, but for n is 1 through to k. So we're going to say u1 is equal to 5, 1 minus 1 plus 1. u2 is 5, 2 minus 1 plus 1. Dot, dot, dot. u k minus 1 is 5 to the k minus 1 minus 1, which is k minus 2 plus 1. And u to the uk is 5 to the k plus 1 minus 1, which is k plus 1. The next step is we're going to prove true for n is k plus 1. So we're going to say u to the k plus 1 by our formula. So we're no longer using this formula because that's what we're trying to prove. We're going to use this formula now. So u to the k plus 1 is 6u n minus 2. This is our formula, 6u to the n minus 2 minus 5u, what was it, n minus 1. Or other way around, n minus 1 is here, u n minus 2. Now, n is k plus 1. So 6u, k plus 1 minus 1 is k, minus 5u, k plus 1 minus 2 is k minus 1. In fact, in our assumption, that's why I wrote out this step. Often we will just write out this step, but we're going to need this one as well. So 6u k is 5k plus 1 minus 5 uk minus 1, we've assumed is 5k minus 2 plus 1. Expanding that, we get 6 times 5 to the k plus 6 minus 5 to the 5k minus 2 minus 5. Now we can actually put this 5 into the k minus 2 and say this is 6 times 5 to the k. Now first up, 6 minus 5 is 1, so plus 1. And we can go, using our index laws, we add these, 1 plus k minus 2 minus 5 times 5 to the k minus 1. And then we can go 6 minus 5, we get 5 to the 1 times 5 to the k plus 1. That's u to the k plus 1. Let's check if that's what we wanted to get in there. So 5 to the k plus 1 minus 1 is 5 to the k plus 1. So we're good. Done. Alright, thank you.